Okay, so welcome to this tutorial. It's all about managing SE Linux security, and it's all about Linux operating system. So we need to understand how do we manage SE Linux security, or what is SE Linux in the first place. So of course, it's all about protecting resources using SE Linux, and what SE stands for, because SE is actually initials, it stands for Security Enhanced Linux. So how can you enhance security in Linux operating system? So apart from the file permissions that we of course know, that is the read, write, execute, we also have the ACLs coming into play. Again, we also have the SE Linux, or the Security Enhanced Linux. So we need to understand how can we do this in Linux operating system. So in this case, there's few concepts we need to understand, and of course we're using Red Hat 8. So when it comes to understanding or how or enhancing security of resources in Linux operating system, we have, or we need to get to know more about SE Linux. So remember that when you talk about SE Linux, it's actually a way of providing a critical security in Linux operating system, or in other words, you can say SE Linux provides a critical security purpose in Linux operating system or in Linux, permitting or denying access to files and other resources that are important or that are significantly more precise than user permissions. So here it means that because we had the ordinary or the traditional permissions, that is the read, write, and execute, all of them are being attached to a file. So you can actually permit or give a permission to or grant a permission to a file or a certain user, or even deny or revoke a permission from a certain user using a certain file. So file permissions control which users or groups of users can access which with specific or with specific files, or which specific files. However, a user given read or write access, you see, a user given read or write access to any specific file can use that file in any way that user chooses. Why? Because he has been given the permission to read the file. He has also been given the permission to modify the file, that is, to write the file. So it means that because he has the read and write, then the user chooses how he uses the file, even if that use is not how the file should be used. He already has a what? He has the permission in place. So for example, with write access to a file, should a structured data file designed to be written to using only a particular program be allowed to be opened and modified by other editors that could result in a corruption? So in this case, you see, instead of or trying to prevent, or in order for you to prevent a file from being corrupted, it's better you initiate these permissions as a security as a security policy. So file permissions cannot stop such undesired access. They were never designed to control how a file is used, but only who is allowed to read, write, or run a file. So you see, we have the differences. The traditional way of using those permissions like read, write, and execute, they were only meant to allow a user to read, write, or run a file or execute a file. But they were not actually meant to ensure that a user has control or can define how the file is going to be used. So that is the reason now why we have what? Why we have the SE Linux coming into play. So SE Linux consists of a set of policies defined by the application developers that declare exactly what actions and accesses are proper and allowed for each binary executable, configuration file, and data file used by an application. Now, with that, or with this, we have a name that is actually referred to as the targeted policy. Why? Why targeted policy? Because one policy is written to cover the activities of a single application. And policies declare predefined labels that are placed on individual programs, files, and network posts. Now, so that is actually like a few, just like a definition of what AC Linux is. But just to know that you'll always have a name like AC Linux. So of course it stands for security enhanced, enhanced Linux. So security enhanced for SE. So this is what it means. Now, when it comes to, for example, let me just open, open a file so that we can just use it as our board. Now, here we are talking about SE Linux, and we are having that it stands for security enhanced Linux. Now, with SE Linux, in this case, we can say it has what? SE Linux has 3 modes. Number 1, we have enforcing. Number 2, we have permissive. Number 3, we have disabled. Now, these are what? These are AC Linux or 3 AC Linux modes. What happens when we have enforcing? What happens when we have permissive? What happens when we have disabled? Now, when AC Linux mode is set to enforcing, when AC Linux mode is set to enforcing, it means that we have the enforcement access control rules, or we have access control rules. And by default, you'll find out that computers generally run this mode. So anytime you have, let's say you've actually installed your operating system for the first time, the default AC Linux mode that is in place is actually enforcing. So it means that we have access control rules. Now, what happens when it is set to permissive? AC Linux is active. That is when the mode is permissive. So the AC Linux is active, but instead of enforcing access control rules that is being done by enforcing mode, it records warnings of rules that have been violated. This mode is used primarily for testing and troubleshooting. So if you want to troubleshoot your system, if you want to test your system, then you have to test it while the mode or the AC Linux mode is at permissive. So it means that as long as the database, not the database, but the AC Linux is active, we have what? We have the recording of warnings. And these warnings are being brought about by the control rules or the rules that are being initiated, and also those that are being violated. Then what happens to the disabled? When the AC Linux is actually at the disabled mode, it means that the AC Linux is entirely turned off, or it is actually turned off entirely. That means no AC Linux violations are denied, nor even recorded discouraged. So it means that the AC Linux is not in place. The security enhanced Linux is not in place, but it will only work. You see the recording of, let's say, violation or violated rules, and to ensure that the AC Linux is active, that is in terms of access control rules, that is only being done at the enforcing mode and at the permissive mode. Once you have the disabled, it means that neither of them are going to happen, because AC Linux is no longer active. So you need to understand the 3 modes of AC Linux. Now, when it comes to the basic AC Linux security concepts, it means that we all know that AC Linux or security enhanced Linux is an additional layer of system security. And the primary goal of AC Linux is to protect user data from system services that have been compromised. The primary goal of AC Linux is to protect user data from system services that have been compromised. So most Linux administrators are familiar with the standard user stroke group, stroke other permission security model, which is being carried out by the read, write, execute, read, write, execute, and read, write, execute. So most of the operating system or the Linux administrators or any Linux user knows about that. But this is a user and group-based model, which is actually known as the discretionary access control. When you have the clue or an understanding of only talking about the read, write, execute kind of permission, or those permissions that are attached to the user, the group, and others, then this type of control is actually referred to as discretionary access control. Now, AC Linux provides an additional layer of security that is object-based and controlled by more sophisticated rules known as mandatory access control. So here it means that we have like two types of controls here. And we have, for example, the first one, which is called discretionary. You can talk about discretionary control or access control. So for this one, it's just the normal, especially when you know about permissions being attached to the user, permissions being attached to the groups, permissions being attached to the others. These are like the common or the traditional permissions. But when you make use of AC Linux, then you're talking about what? Mandatory access control. And you know the importance of this. We have, let's say, access control rules. We also have the recordings of warnings based on the rules that are being violated. And this is what? This type of security is actually object-based. It is actually object-based. Now, so to allow remote anonymous access to a web server, firewall ports must be opened. And you know the importance of firewall. When you talk about firewall, it's more like preventing. So when you have ports opened, it means that you can actually, let's say, invite anonymous access to a web server or different visitors or anything that comes within the web server. So what happens is, if you have the firewall ports closed, then it means that you're doing what? You're actually denying remote anonymous access to either web server or to any other server. So this case, it means that when the firewall ports are open, it gives malicious people an opportunity to crack the system through a security exploit. So if they succeed in compromising the web server process, they gain its permission. So specifically, the permissions of the Apache user and the Apache group are being done what? Are being compromised. So that user and group has read access to the document root. And again, it's also access to, let's say, one of the root directories or the file system root directories is actually, for example, the /tmp and probably the /var/tmp and any other files and directories that are world writable. So AC Linux is a set of security rules that determine which process can access which files, which process can access which directories, and which processes can access which ports. So every file, process, directory, and port has a special security label called an AC Linux context. So we have something called AC Linux context. So this one is a special word, AC Linux context. And this is actually like a special security label. So you can define that is a special security label attached to either the file, the processes, the directory. Sometimes you have the directory. And of course, you can also have, last but not least, we also have the ports. So these are what? These are very important concepts, because when it comes to using, let's say, the ordinary or the traditional file permissions like read, write, and access, read, write, execute, you see, we are only considering the file. But what happens to the process? What happens to, let's say, the ports? Are we actually more secured when we use the traditional way of using either the ACLs or using even the normal permissions, that is the read, write, execute? So in this case, it means that when we talk about a context here, we are talking about a name used by the SC Linux policy to determine whether a process can access a file, directory, or code. And what happens? By default, the policy does not allow any interaction unless an explicit rule grants access. You see, by default, the policy or the SC Linux policy does not allow any interaction unless an explicit rule grants access. If there is no allow rule, no access is allowed. So there's a configuration file attached to this. So you have to do what? You have to change. And when we talk about unless explicit rule grants access, it means that this access needs to be done by the user. You see, we have the opposite of implicit and explicit. Implicit, that means as being done by the system automatically, but explicit, it must be modified by the user. Now, AC Linux, again, has roles, or let's talk about labels. AC Linux labels. So AC Linux labels have several contexts. AC Linux labels have several contexts. For example, we have user, okay, we have role, we have type, and we have sensitivity. So these are what? These are AC Linux labels. So you will find out that we have the user, it will start user, then role, then type, and lastly is actually the sensitivity. So the targeted policy, which is the default policy enabled in Red Hat Enterprise Linux, bases its rules on the third context. And the type context, so we have the third context, which is actually the type context. So which type of file are we referring to? Now, the type context names usually ends with -t. It ends with -t. So you'll find that we can have a file such as this. We can have, let's say, unconfirmed or unconfined _u, that is the user. We can have object _r, that is role. We can have httpd _sys _content, and then _t, which is actually the type. And then we can have probably now the file that comes middle after that. We can have a file such as so, and then let's say var ww to a world writable file now, HTML, and then you can have either file, file2. Now, in this case, you'll find out that this is what? This is now the AC Linux labels. So you'll find that because we have this in uniform or in position, so we have, or in order, user has to start. And you can see that all these are being separated with a full colon. And confined _u, this represents the user label. Object _r, r represents the role mode label. HTTPS _sys _content _t, t represents what? The type label. And then now the final part represents the sensitivity. That's why you see it start with what? It starts with S. So the type context for a web server is actually HTTP, HTTPD. It's actually HTTP, HTTPD. And when it comes to that, we can talk about HTTPD. So that is the type context of a web server. The type context for files and directories normally found in the, let's say, for example, the var, this one, like /var www HTML. So the context So the context for files. So the context for files and directories normally found in /tmp are what? They have the underscore. They have the underscore t. So in this case, you'll find out that even if you talk about the type context for web server ports, it will have what? If you talk about, let's say HTTP, we can talk about like HTTPD or HTTP underscore port underscore T. This is actually the type context for a web server port. So that is it. So this is all about what? The AC Linux labels. And we're talking about the AC Linux labels based on the type context. So we have a lot when it comes to that. And you need only to understand how do we view, let's say, for example, how do we check all this? Let me just show you practically how we can do this. So quit, let me clear the screen. And then we can have, let's say, PS, and then A, X, Z, just to show. Now here, let me have this. Let me just have the few, or let me have the first 5 lines here, -N, 5, and then we can have P, S, A, X, Z. Okay, this one is not going through. Okay, so let me just give you in full so that you can understand, just to see how it works. Now look at this. For example, we can choose one. This one we have unconfined underscore U. We have unconfined underscore R for the role. We have unconfined underscore T for the type. And then of course we have the sensitivity coming here. So each one of these, look at this for the system. We have system underscore U. This one is what? This one is the user. System underscore R, this is the role. We have kernel underscore T, this is the type. And of course we have the sensitivity. And all these are there. So all this is actually representation of what? The AC Linux. Now, if you want to start, let's say systemctl, we can have a start. Let me see whether I have this, HTTPD. Let me see whether we have this. Of course, I should do this as a root. That's why, okay, su red hat. Okay, so if I do this, systemctl start. Okay, first of all, let me check the status. PD. Okay, HPD service not to be found. In this case, let me see whether I have start. Okay, fail to start it. Okay, I think it's not there. Now, when it comes to that, if you're to start that service, which is actually HTTPD, and then you query this command ps-capset, that is C, and then use HTTPD, then you see, for example, we do not have any what? We do not have any AC Linux attached to it because this service is not there. Now, let me show you a service that exists. Systemctl status sshd.service. Yeah, so this service is actually active and running. Now, let me come and check now. Let's check for the SSHD. Now, you can see for this particular service, already we have what? We are able to see the AC Linux security feature attached to it. So it is actually the system, the user is actually the system itself. That is the user. We have the role. We have the type is actually SSHD_T. And then of course, we have what? We have the sensitivity, and then followed by the process ID, the terminal, and then of course we have the time executed, and then the name of the command or the name of the service itself. So this is how you do what? This is how we view. This is how we view the AC Linux security feature attached to a service. And you can actually have a lot. Let's say, for example, can you clear the screen? We all know that if I go pwd, we have this, but let me just change it to home. Let's say pwd. Okay, it is root. Now let me check the Selinux for home, ls-Z. So if you want to check a security, that is the security enhanced Linux for, especially the Selinux label context attached to a particular directory, you can actually use uppercase Z. And you can see now that whatever objects that are in here, this particular directory, each one is attached to a security, a Selinux label. So we have, this is unconfined, we have the role, we have this is the type, and of course we have the sensitivity attached to it. Now, this is it. How do we change the current Selinux mode? That is the question now, because we've actually viewed how do we change the current Selinux mode. Now, the Selinux subsystem provides tools to display and change modes. To determine the current Selinux mode, run the get-enforce command. You have to run the get-enforce command because this command is what? Is well attached to what? To Selinux. That means if you want to find the current Selinux mode, is it enforcing, is it permissive, or is it disabled? Now, again, to set Selinux to a different mode now, from the current one, you have to use a command called set-enforce. So set-enforce, you have to use that. Now, when it comes to this, when it comes to using now enforcing, we have a value attached to it. We have 1 attached to enforcing. Then we have permissive attached to what? Attached to 0. So whenever you are setting, if you're switching to enforcing, you have to use 1. If you're switching to permissive, you have to use 0. Now, let's assume that I want to see get enforce. Press enter. You see, my default Selinux is actually what? Enforcing. Now, this means what? It means that I have access, control, rules. It means that the rules are already in place in terms of protecting my resources using a Selinux. Now, if I'm to put to permissive, it means that, yes, the enforcing mode will be active or the security feature is on, but this time around, there will also be a record of warnings coming from any rule that is being violated. Now, let's see the set-enforce without even putting anything. This is what I was saying. We have 2 types, especially the most active ones, the enforcing and the permissive. So enforcing is attached to what? Permissive is attached to what? 0. Enforcing 1, permissive 0. That is how to set enforce. But now let me see whether I can set it. Set enforce, we know by default it is what? Enforcing. And enforcing here is attached to 1. Let me give it to 0. Set enforce 0. Press enter. Now come and recheck it. Get enforce. Now you can see that I have successfully managed to change what? The Selinux permissions from enforcing to permissive. This is how you set. If I have to bring it back, I need to change it to 1. And then when I come back to get enforce, you can see that I have actually made enforcing my default and current what? Current mode. So that is how to change the current Selinux mode. At some point, what happens now if you don't want to use what? The name. We know by default it's actually at enforcing. Am I able to use the name? Now let's see. Set enforce. Set enforce, and then I have permissive. Yeah. So you see already it's also doable. So if I come get enforce, yeah, you see that it's changed to what? To permissive. Now, if I have to get back, now let's come to enforcing. Yeah, then get enforce. Yeah, so it's actually okay. It is okay. Now, setting the default Selinux mode. You see the default now. Setting the default Selinux. These are apart from how to change. So you can also configure Selinux persistently. You see, we have like the setting of the Selinux modes either temporarily or persistently. So whatever thing we've done is actually temporarily. But what happens if you want to set or configure Selinux mode persistently? That means permanently. Now, by so doing, you have to perform the configuration on a file. This file is actually a configuration file. So we have this file, which is etc. You can have a Selinux, and then we have config. We have this particular file. Now, by example, you will also see the default word configuration. And let me show you this so that we can prove it. Get enforce, it is enforcing. Now let me change to 0. So if I come back to this, you can see it is permissive. It is permissive. Now I want us to confirm now from the configuration file whether it is what? Whether it is permissive or it is enforcing. So it means that by default, we always have a mode, and this mode is by enforcing. So let me just do the cut and then etc, because it's actually a configuration file. I will have a Selinux and then have config. Press enter. Now look at this. You see, we successfully managed to change the mode to permissive. But look at the configuration file, which is config. It is actually at enforcing. It is actually at enforcing. And the Selinux type is actually targeted. So in this means that even if you do it by using set enforce, get enforce, as long as that session is active, it will always be there. But once you even restart your operating system, persistently, it's actually at enforcing. So unless you change it from the configuration file, and how do you change it? You have to use vi, let's say etc, Selinux config, press enter, and then press I, and then come and change. So for this one, you can give it permissive. So that is how to change. And then you save it, WQ. Now, in this case, it means what? It means that now that by default, persistently, it is actually set to what? It's actually set to permissive. Permissive. So you can see now that it's permissive. Now, what happens if I go back and change it? It is actually enforcing, colon. So if you go back again, get enforce, it is permissive. So it means that if you change it persistently, it will not reflect automatically on this other side. So if I have to take it back for this one, set enforce 1, press enter and bring it to that, and becomes enforcing. So those are two ways on how you can set your default Selinux. That is how you can set your default Selinux. Now, controlling a Selinux file context. How do we control a Selinux file context? Now, in this case, you see, we have something called this SE manage. We have this concept, SE manage. SE for security enhanced to manage. But remember, commands in the Linux operating system are basically being executed while they are at lowercase. So we have saying SE manage. Now, what is this command used for? Of course, if you want to know more about a command, you can just use man, and then it will display. So SE manage is actually security Linux, or SE Linux policy management tool. And of course, you can get more information about about this. Now, so if you want to manage the Selinux policy rules that determine the default context for files and directories, then you have to use what? SE manage. Then if you have to, let's say, apply the context defined by the Selinux policy to files and directories, you have to use another command which is called what? Restore_con. So restore_con is a command used to apply the context defined by the Selinux policy to files and directories. So first of all, you can define what Selinux policies do you want, and then where am I going to apply? So once you find that you want to apply to a specific file, whether it's a file or directory, then you use the restore_con. So the restore_con now will apply the policy or the Selinux policies now to that file after it's been defined by what? By the SE manage. Now, so for the initial Selinux context, you see, all systems running in Selinux, all processes and files are labeled. They must be labeled. And how do we label them? We label them by the user, by roles, by type, and by sensitivity. So the label represents the security relevant information. And this type of security relevant information, or the label representing the security relevant information, is actually referred to as the Selinux context. So once you have the Selinux context, it means that you are actually using the labeling. So new files typically inherit the Selinux context from the parent directory, and that ensures that they have the proper context. So we are going to have a look at how do we check this. Now, so since we have the files, in this case, let me just take you to desktop. Let me have like RH8 and then desktop. So in this case, let me see whether I have this. So let me clear everything here, ref, then star, then clear. So let me touch this file, let's say file 1, and then mkdir, let's say box 1. So ls, box 1 is a directory, file 1 is a text file. Now, if I want to view the Selinux context for every file, whether it's a directory or a .txt file, I have to do what? I have to use ls-caps-z. ls-caps-z. That's what displays the Selinux context of a file, not the label of the file. So if I press enter, you can see that I'm getting what? The context, or the Selinux context of these files. Now, and you can see that here we have the user, we have the role, we have the type, and we have the sensitivity. Now, what happens if I use ls let's say zd? Now, ls-zd displays the Selinux context of a directory. So if you want to specify the directory alone, then it will be given by this particular command. So if you put D, it means that it will now identify all the available directories and displays what? The Selinux attached to those directories. So, but when you use only ls-caps-z, it will all give you what? It will give you the Selinux for all the files. So for this case, if you want to change the Selinux context of a file, let's say, how do I change the Selinux context of a file? So let's do it practically. So first of all, we have this particular file called what? Or this directory called box1. Now, if I come back and say ls-capzd and then box1, press enter, you can see that I have this Selinux context. But how do we change? How do we change? So to change, again, gives you a platform to use more commands. So here we have a command which is called chcon. Chcon is a command that changes the file context of, let's say, the box1 directory, and the type value changes to either we can have, let's say, to httpd underscore sys underscore content underscore t. So let's change. This is where we are changing from being user underscore home underscore t. So let's change. I will use -t for type, httpd underscore sys underscore content underscore s. And then I will have what? I will have box 1. Failed to change context of box 1 to unconfined object to pieces content invalid arguments. Okay, so I don't know, it's either missing the, so we have chcon, let's say box 1. You cannot access box 1 or such file or directory. Let me give it for file 1. Okay, something is being brought. I think the issue is about that service is not there. We can give it. So with this, it means that the command itself, because it's a directory, and I can change it, let's say, to box 1. -t, you see, change context, ch for change, con for context, -t, httpd underscore sys underscore content underscore s. Is it s or t? Yeah, t for type. Yeah, httpds underscore sys underscore content underscore t. Okay, and then let me press enter. Yeah, I think it's changed now. There was an error here. So if I just use -zd and then probably box, now you can see that I have successfully managed to change. The SC Linux context. So by using -type, it means that I am able to change the type itself. And then I'm giving or attaching the type. So it should be _t, not _s. That is where we're getting the errors. Now, after changing that, you see it is temporary. It is actually temporary. So even if I restart my system, it will always go back to where. So what happens is we have this other command, which is called what? Restore con. Now, the restore con command runs and type value returns to the value of the default _t. And what happens if you use the restore con? Let's see how it works. So I will say restore con -v, and then I will have, let's say, box 1. Press enter. So I have done something called the relabel. So relabeling the message. Now, what happens if I go back and check the contents? So you can see that I have actually managed or successfully managed to revert or to actually bring back the state of the type context to where it was. So with this one, it means that you are able to do what? To change context. But with restore con -v, you are able to bring back, the what? The context itself. So we have changing, and of course we have having like you're restoring it back. So how do we define AC Linux default file context rules? How do we define AC Linux default file context rules? So we have the SC manage file, and the SC manage, if I just use SC manage, it's actually a command, and then you can have like F context. SC manage F context is used to do what? It's actually a command used to display and modifies the rules that restore con uses to set default file contents. So if you want to set or modify the rules that are being explained in the restore con, then you can use what? SC manage F context. So you'll find that with this particular command, it uses extended regular expressions to specify the path and file names. So the most common extended regular expression used in F context rule is /.star. So we have /.star. So which means what? It's actually like optionally match followed by any number of characters. So we have this particular tool or this particular command, which is called manage f context, used to display and modifies the rules that Restocon uses to set default file context. So you have a lot when it comes to that. And in this case, we can just have an example. How do we use this? So I'm going to base it on what? Let's say box 1, or I'm going to base it on file 1. ls-z file 1. Let's see. So for file 1, this is the Linux context. Now let's do this. ls, I can have, you can repeat the same thing. And let's say star, if you have, you see, we also have everything in there. And if, for example, let me cd to box, and then let me touch 1, 2, 5, and then come back one step back. So it means that if I do ls box, I am able to see 1, 2, 3, 4, 1, 3, 5 files. Now what happens if I just say ls-zd and then box and then star? So you see it's giving me what? It's giving me the AC Linux context for all the files. First for the directory box 1, and then it gives me everything in there. Now if I come and use SC manage now, if I come and say use SC manage f context -l, press enter, you can see that we have a lot of info. We have a lot of info that are coming in. We have a lot of info that are coming in. And these are what? These are all files or all the Linux files whose Linux context have been defined by the Restocon. So if you want probably to relabel them, you can bring back the relabeling. So now in this case, manage is actually a tool. It's actually an important tool, especially when it comes to modifying the rules that are set on the Restocon. And we can actually see how do we add, let's say, how do we use manage to add a context for a new directory? How do we use this? So just the same way, I can have this directory. Let's say we can have it as book. Of course, we have book there. I can come back and say touch book, and then we have, let's say, index.txt. So I am actually, so ls, you see, where is book? Where's book? Okay. So I'm supposed to give it under book. Okay, so touch. Oh, never. So mkdir, I want a book. And then ls, we have book. So let me clear. Then we come back here and have it as touch book. And then we have, let's index.txt. So if you come back here and say ls book, press enter. So ls book, and then ls book index.txt file. Now, what happens here is that if I have to look at the AC Linux for book, you can see that it's giving me this, the index.txt. So by default, I'm having this particular file. But now, how do I add a context for a new directory or a context for this? So for that, I need to have like a cmanage, and then have f context, and that f a, then f t, and then f httpd underscore sys underscore, let's say content underscore t. Then I can have, for the directory now, I can have, let's say book, then of course I can have this, put that dot, and then star, and then put that, and then question mark, and then you can close it. Press enter. So this is all about what? Adding a context for a new directory. And now when I come back to restocon, just to confirm how it is, -r, capital F, and then VV, I can give as book. And then if I press enter, yeah, it will go through. That means I've managed to successfully change it. Now let's see ls-capz d, and then book. Okay, so you can see that I have, okay, I don't know what's happened. It's supposed to have taken this. So the type part here are supposed to be changed by the system. Now again, let me just use -z. So we have user underscore home underscore t. So for this, it's supposed to have taken what? The httpd underscore sys underscore content underscore t. That means on what? On this part, on the book part. Okay, so it's all about relabeling. So probably, don't know what's wrong with that. Okay, and so that is how to do it. How to use that. They'll still see it, what happens. And now this brings us to something else about a Selinux booleans. So when we talk about adjusting a Selinux policy with booleans, what is this boolean we're talking about? So a booleans or a Selinux booleans are just but what? So you can have a Selinux booleans are just but switches that change the behavior of the Selinux policy. So you have a policy in place. To change the behavior of the state of that policy, you need to have something called the Selinux booleans. So Selinux booleans are rules that can be enabled or disabled. So you decide, do you want it enabled or do you want disabled? That already takes care of what? The behavior of the Selinux policy, which is actually the enforcing, the permissive, and lastly, the disabled. Now, Selinux booleans are rules that can be enabled or disabled. They can be used by security administrators to tune the policy to make a selective adjustments. So the Selinux man pages provided the Selinux policy doc package describe the purpose of the available booleans. So if, for example, I'm to run this command, let's say man, and then -k, let's see whether we have, and then I can have underscore the Selinux, press enter, nothing appropriate on that. And we will see this. Now, just to know that they are what? They're basically meant to switch the change the behavior of what is Selinux. So they are switches on, off, yes, no. Now, the useful commands attached to this includes, we have a command called getSebool, which lists booleans and their state. getSebool lists booleans, their state. And we also have setSebool. So we also have this setSebool. We also have setSebool, which modifies the booleans, Now, I can also have setSebool -p. -p means what? It modifies the Selinux policy to make the modification persistent. So P for persistent. And again, we can also use them. If you remember the SC manage, SE manage boolean -L. I can use this. So this reports on whether or not a boolean is persistent along with a short description of the boolean. For example, if I press enter this and execute, let's see what happens. Yeah, it's all about on and off. So it's more like a switch. So SE manage boolean -L, this one will list or give you a detailed report on whether or not a boolean is persistent along with a short description of the boolean. So on it means that like allow X guest to mount media. So let's go step by step. One, we need to have get sebul. Get sebul -A. Get sebul -A will do what? This one will define or will actually list booleans and their states. Press enter. So you can see that these are the booleans and their states. So we have on, we have those that are ons, we have those that are off. So we have two ways, they are switches, on or off. Now, if I want to go specifically to one, I'll just say get sebul, and then let's say httpd pd underscore enable underscore, let's say okay, for example, you see that this one is only one. So you can see that it is off. Now I am getting this concept from where? I'm getting it from here. So I can choose to work with one. If I want to check a specific what boolean, if I want to check a specific boolean, I can actually work with that. So there are so many booleans. So that is how you narrow them down. If you want to get one of them, that is how you want to narrow them down. So let's start for one. Let's see how we can change one. And let's have something like send run kemu. So get sebul. Let's say send underscore run underscore kemu. Then, so if we check that, you can see that the status is what? The status is send underscore run underscore kemu. Now the status what? The status is on. So how do we change the status? How do we change the status of this? So yeah, how do we change this status? So by viewing, it's only about get sebul. Now by probably changing it, I will need to use set sebul. Set sebul, and in this case, I'll just use send underscore run underscore. This time around, I will put it what? Off. Press enter. So if I come back and say get sebul to that, you can see now I have actually successfully done what? Switched off. If you want to bring it on, just rechange it again, and it is on. The same thing happens to the first one. Where was that? Yeah, this one, it was off. If I want to put it on, I will just choose what? Set sebul. And then at the end, I'll just put on. Come back and check it. It is on. And put it off. Yeah, that is it. So come back again. Yeah. So this is how to do what? This is how to change or how to switch or how to set the booleans. How to set the booleans. How to set the booleans. So if you're to use, let's say, -p option, it means that you're trying to write all pending values to the policy, making them persistent across what? Across reboots. So this is what happens. So if I want to put it this way, let's say set sebul, and then I can put it, of course, we know that it is off. Now, if I want to turn it on or set it on, I will just put -p for persistent. That means it will survive what? Reboot. And then here you will put what? On. You will put on. So the only thing you add there is what? Is -p. So when you come back here, of course, it is on. And this means what? It will survive the reboot. It will survive the reboot. So if you want to say, let's say specifically, if you want to check it specifically, you can just say AC manage boolean -L and then put this simple and say grep. You want to see the status and also the short explanation. It's PD underscore enable underscore home dirs. Now you can see what it is on. So allow HTTPD to enable home directories. So this is how you check what the list, the detailed listing of all the booleans. Now to list booleans in which the current state differs from the default state, you have to run what? The boolean -L, then cap C. So this will do what? This lists the booleans or the switches in which the current state differs from the default state. So with that, that brings us to the end of how to adjust AC Linux policies with booleans, and of course, introduction to AC Linux in general. So with this, it means that if you're to work with probably the investigation and resolving AC Linux issues, you don't have any problem, especially when it comes to troubleshooting AC Linux. You have to consider all those commands. So here it means that if you're given some task to work on, it will be as easy because now at least you know what is happening. What is an AC Linux, which is also an advanced security feature to the same files and folders, especially to the users and the groups that owns files, or those that have access to the files. And when you want a more advanced permission, especially for security feature when it comes to the ports, the processes, the files, the directories, then the AC Linux is there for you. So up to there, probably we can stop there for today and for this particular tutorial, and I'll see you in the next video. Thank you.